Hello everyone, I am Kiran Sara Thomas, final year BTech student from Rajgir School of Engineering and Technology, Kochi. Topic of our research project is Intelligent Transformer and our team members include Melvin Benny, Roy J. Matthew, Sebin Jose and myself Kiran Sara Thomas. We thank IJNTR for giving us this opportunity to present our research based on transformers. We know that transformers play a vital role in distribution and transmission systems. So, the proper operation of distribution transformers is an important criteria of an electrical distribution network. The transformer life is impacted by heating, overloading, and various faults occurring in the electrical network. Improper functioning may lead to an unreliable supply network. The present monitoring systems are not efficient enough. The time required in data acquisition of various parameters and testing speed is very high. Many monitoring systems use power communications to send the acquired data. They introduce difficulties such as electrical noise and frequency interference. So, we need a system that monitors all system parameters and sends data to monitoring centers in time. The proposed system provides online transformer health monitoring, data acquisition, and fault prediction system. The system presents the realization of a cloud-embedded system to monitor current, voltage, temperature, humidity, and oil level. The system integrates the Internet of Things with appropriate sensors and relays. The data obtained are processed and recorded in system memory. Based on predefined conditions, the system checks for abnormal conditions and proper actions are carried out. The fuzzy logic controller is implemented for incipient fault prediction and diagnosis fault prediction. The main objective is that the proposed system prevents the occurrence of faults and losses in the power supply, provides self-protection in case of any fault, employed to monitor multiple transformers closely, enhance system stability and reliability, avoid the occurrence of power and data losses as wireless communication is achieved. The usage of Wi-Fi aids to achieve more accuracy and quick response in fault monitoring. Fault prediction and diagnosis of transformer performing dissolved gas analysis. The block diagram represents the proposed monitoring device system. Various parameters such as current, voltage, temperature, humidity, and gas levels are measured using the various sensors, and a microcontroller is employed in the system to perform computation. Real-time monitoring is achieved in the system using IoT platform provided, and the Wi-Fi module is worked to achieve wireless communication. Based on the occurrence of fault depending on predefined instructions, the relay employed in the system gets activated and protect the transformer. The gas sensors employed in system perform dissolved gas analysis and predict the occurrence of incipient fault using the fuzzy controller designed based on the various gas concentrations. Now let's take a look at the various hardware components included. First, we have the supply circuit. We use 230 volt 50 Hz AC supply in general, but the microcontroller provided operates on a 5 volt DC supply, and so the AC supply should be converted to a 5 volt supply using a step-down converter provided in the power supply circuit. The AC power is then converted to DC using a power electronic rectifier circuit. The circuit consists of a bridge rectifier circuit for power conversion. The pulsating DC is with ripples and is filtered using a capacitor filter. To obtain the required 5 volt voltage regulator IC7805 is used. Next, we have the voltage sensor. The voltage sensor comprises of a rectification element, a potential divider circuit, and a regulation device, and the output of the sensor is fed to the microcontroller, which reads the corresponding value and displays the original value of voltage. In the proposed system, the current is measured using sensor ACS 712 30 ampere. The sensor yields accurate current measurements. The ultrasensor used in this research is the HCSR04. The DHT22 is used to measure the temperature and humidity. Gas sensors are utilized to detect the concentration of various gases in the transformer tank. Depending on the various gas concentration ratio, a fuzzy controller is created. MQ4 and MQ8 sensors are proposed in the system. MQ4 sensor has sensitivity towards methane, propane and butane, whereas MQ8 has sensitivity towards hydrogen. We use Atmega 328 as a microcontroller incorporated in Arduino Nano. The relay module used is SRD 05V DC SLC. ESP8266 is used as the Wi-Fi module. Coming to the software requirements, we have Arduino IDE, which is an open source Arduino software that makes it convenient to write code and upload. The fuzzy rule based codes were incorporated using this software. ThingSpeak.com was used as the IoT software. ThingSpeak is an IoT cloud platform where you can send sensor data to the cloud operated by the MathWorks. MATLAB was used to design the fuzzy controller for the fault diagnostic of the transformer. Coming to the working principle. The proposed system consisting of sensors and relays are integrated at the low voltage side of the transformer. The microcontroller Arduino receives and processes various sensor data, that is voltage, current, temperature, humidity, gas level and gas ratios. Real-time monitoring is implemented on system, so data are transferred to IoT platform through wireless connection provided and reaches to the respective officials. On the occurrence of abnormal conditions, the system detects it and alerts the officials. Relay implemented protect the whole system from it. The fault prediction system is developed using dissolved gas analysis. Dissolved gas analysis is a method by which various gases formed in transformer are being studied for fault prediction. Using the gas sensors, gases such as hydrogen and methane levels are obtained and provided to the controller. The system studies are different. Gas ratios specified and obtain the gas code. Fuzzy logic is a generalization of standard logic in which a concept holds a degree of truth between 0 and 1. Using the fuzzy logic, gas ratio codes are studied and corresponding fault weight is predicted. These are the experimental results we obtained during the project. The figure shown here shows the result of the temperature output of the transformer in the IoT platform. The figure below shows the results of the gas ratio of CH4 and H2. The given figure shows the working of the fuzzy controller, diagnosing the fault and suggesting a maintenance plan based on the rules provided for the fuzzy controller. To conclude, the project focuses on enhancing the performance of the distribution transformer monitoring process. The whole system ensures high transmission reliability and performance. The suggested scheme is cost-effective and reduces the likelihood of human error in transformer control scenarios. Relays embedded with different sensors provide adequate reliability and security with improved performance, and the Wi-Fi module assists in sending the operation details with the aid of the IoT platform to the control room where the required data is stored in the cloud platform. The data received will help the utility to keep a check on the operational behavior of the transformers and identify faults before any failures. In addition, the system provides a pathway to tackle with necessary measures in case of emergency to the transformers. Also, data incipient fault prediction and diagnosis of transformer faults using fuzzy logic are implemented. Thank you.